Hello, today we are going to learn a little bit about vectors. First of all, a vector is a directed line segment, and we use the notation V with a little ray above it. In geometry, we'd call a vector array. All right, a vector has both magnitude, which is size, and direction. A scalar has only size, such as distance, time, or volume. Anytime you see the word scalar, just think some sort of number or constant, like 5, -3, something like that. We can have our vectors go in any direction. They can go up, they can go, down. We could go that direction. Whichever way we want our vectors to go, they can go. We do have a couple vocab that we use. We talk about the tail of the vector being the endpoint and the head of the vector being the arrow, the ray that shows which way it's going. When you see absolute value signs around your vector, what that's really asking you to do is find the magnitude of the vector, which is the same thing as the length. So we should be getting a scalar or a number when we're asked to take the absolute value of the vector. And it's important to know that two vectors are equal if and only if they have the exact same magnitude and the same direction. All right, so let's talk about doing some operations with vectors. The first one we're going to look at is just adding our vectors together. So when we add two vectors together, basically all we have to do is we take the one vector, A, and we add it to vector B by moving the tail of one vector to the head of the other vector, and then drawing in the resulting line segment here. And so that right there, and I just want to color it something different, so it's a different color, is A plus B. Similarly, we could take vector A and then vector B and put them so they're opposite. So the tail of A is now on the head of B, and then that vector right there will be the same as the blue vector. All right, so now we're going to look at finding the magnitudes of sums. So what we need to do is first draw in the resultant vector. So the resultant is just when you add the two together. So what I'm going to do is I'm going to move the tail of B to the head of A, and then I'm going to draw in this line here. Okay, and so that vector right there is A, B. Let me just clone that so I can actually not necessarily move it for good. It's important to realize that angle 52 is this original angle right here. And then we have to go back to geometry a little bit. And what we've got here are two parallel lines and a transversal. And we had all kinds of names for these. Same side interior, corresponding, alternating interior, all those wonderful vocab words that we might have forgotten by geometry time. But if you look at these two angles right here and here are what we call same side interior, because they are on the same side as the transversal and they are on the inside of the parallel lines. And what we know about same side interior angles, and you could maybe guess this, although guessing isn't what you want to do always, from the picture, is that they are supplementary. And supplementary means they equal 180 degrees when you add them together. So if you know that this angle here is 152, then you know this angle is 128. All right, and we moved vector B here up here, so we know that length is 29. We know this vector A has a length of 12, and we need to find the resultant vector A plus B. This should bring us back to day 1 after break when we talked about having side, angle, side, and we want to use law of cosines in order to do that. So now we set up our law of cosines, and my resultant vector squared will equal a squared plus b squared, and I know b is 29, minus 2ab cosine c. Making sure our calculator is in degrees, let's just go ahead and type this in. So I have 12 squared plus 29 squared minus 2 times 12 times 29 cosine of 128. Hit enter, and I get 1,413. Again, please be careful. That is not your answer, and you could look at that and say logically that doesn't make sense because one side's 29 and one side's 12. So I have 1,013 just doesn't really seem right. So I go ahead and take the square root of this number. I always like to raise things to the 1/2 because I think it's easier to do in my calculator than take the square root, but whatever you want to do. I get 37.59. We're just going to call that 37.6. So take the square root of that. And you found the magnitude of your resultant vector is 37.6. And I guess there are no units, so we don't have to worry about units. All right. Let's see what else we got here. Another problem, very similar. It wants us to sketch the resultant vector of a plus b. So basically all I'm going to do is take vector b here and trace it. Oops. And then place the tail of b on the head of a. And then draw from the head, or sorry, the tail of A to the head of B, and that will be A plus B. Okay. Again, you might want to use the idea if you know this angle here is 23 degrees. Same side interior means that this angle here is 157 because 180 minus 23 equals 157 degrees. All right, we also know the magnitude of B was 3 originally, so it's still 3 up there. And we have the magnitude of A is 8, and so now we just do law of cosines yet again. 8 squared plus 3 squared minus 2 times 8 times 3. Cosine 157, plug and chug. Go to my calculator, 8 squared plus 3 squared minus 2 times 8 times 3 times cosine 157. Hit enter, and then remember we always have to take the square root of that number, and we end up with 10.82. So the magnitude of A plus B equals 10.825. All right, so I kind of done that problem already. So sorry, this problem just asked me to sketch a resultant vector, which is this part. And then I just jumped ahead to what I knew they wanted me to do later, which was find the magnitude. And then the new thing, they want to do is they want to find the sine, find the angle between the A vector and the resultant vector. So again, I'm just going to draw this picture. So I've got my head and my tail, and then I've got to draw the resultant vector in there. Okay, so this guy here is A plus B. They want to find the angle between A and B, which is that little angle there. Please, again, make sure you realize that angle there is 23 degrees. So again, we know this from our work that this was 157. And we also found that this was 10.82. So now we can do law of sines. So we can use the idea that I have sine of 157 over my 10.82, and I'd be careful to round. I'd use what I have in my calculator rather than writing 10.825 equals sine of C, so we're just going to call this angle here C, that little angle, over, and we knew the magnitude over here was 3. And so now we just go ahead and cross multiply. So I'm going to multiply this side by 3. Type that into my calculator. So I have 3 times sine of 157 divided by my answer, so second answer. Hit enter, and I get some decimal, 0.108. So I'm going to write that down. And then I got to solve for C, so hopefully we remember that means I have to take inverse sine of that decimal. Again, please don't round, use your calculator. All right, and so I'm going to do second sine, second answer, hit enter, and I get 6.21. So C is 6.21 degrees. Again, we should know that it's going to be less than 23 degrees. So if you got anything over 23, that should have set off a red flag. All right. Now, again, some of you might be thinking, oh, there's 2 answers to this because anytime you do inverse sine, you also have to do 180 minus that answer. Oops. But you already have one obtuse angle in your triangle, 157. So since you already have one obtuse angle, you know that this can't be 173 degrees. And again, you know it has to be less than 23 degrees because that vector is from B to A is 23, and you can see the resultant vector cuts it in the middle. So, or not necessarily in the middle, but cuts it. So we have an answer that has to be less than 23 degrees. All right, let's try a different problem. So now we have same idea. If you think you know how to do this, go ahead, stop the video and try this problem out on your own, and then check to make sure you did it right. All right, so again, I'm going to start with just grabbing my result, I'm tracing my vector so that I can move it, put it right there. And now my resultant vector, let's do a different color. It's going to have an arrow on both sides is the only problem. I'll just go this way. And now I'm going to trace from the beginning of A, head to tail. Okay, so that is A, B. So that was the first thing they wanted me to do, is just sketch the resultant vector. Then the next thing they want me to do is find the magnitude. So I'm just going to find the magnitude right on that same sketch that I did. So find the magnitude. So again, I'd have to use the idea that if I know this angle from here to here is 152, then I know that this angle here is 28 degrees because I do 180 minus 152, and I end up with the 28 degrees. And I know that the magnitude of angle B, or sorry, vector B was 40. So I put 40 on vector B there that I've moved. And then I do law of cosines and come up with this answer. So I have 40 squared plus 300 squared minus 2 times 40 times 300 cosine of 28. Run to our calculator and type that magical equation in. Oops. 40 squared plus 300 squared minus 2 times 40 times 300 cosine of 28 degrees. Hit enter, take the square root, and you have found the magnitude to be 265.34. All right, now the last question they're going to ask us is to find the angle between vector A and vector A plus B. So you can see that's that little angle right in there. We know that this resultant vector we just found was 265, so I'm going to leave that there. And I'm just going to set up law of sines. So I have sine of my angle, which was 28. Again, I wouldn't just use 265 here. I'd go back and use my calculator. And then I don't know what that little x is, but I'm going to go figure it out because I know opposite x is 40. All right, and then I go through here and I multiply both sides by 40. Type that into my calculator. So I'm going to do 40 times sine of 28 divided by this answer, the 265. Hit enter and I get 0.071 equals sine of x. And then to find out what x is, I do inverse sine of the answer, and I get 4 degrees. .058 is what I have. All right. This concludes our first day on vectors. We will work on vectors tomorrow. Please try the on your own problem, and we will work some more in class. Thank you. Have a nice day.